crude oil since time immemorial. Formerly it was used to heal animals and was added to wick lights. Crude oil was also used for military purposes. Fire arrows and the famous oil-based Greek fire were feared weapons. Many centuries passed before people learned to process this unique bounty of nature and to recover different fractions through distillation. The first crude oil storage reservoirs looked like normal lakes. In 1878, the first cylinder-shaped metal oil tank was built as per the design of the Russian engineer Shukov. The structure proved to be so successful that it is still used for oil storage in all countries of the world. The fact is that crude oil is a complex chemical essence and irreversible changes occur in it during storage. Having entered the tank, light fractions gradually evaporate, while heavy fractions settle down to the bottom, forming a thick tarry deposit, oil sludge. Large quantities of tarry solids also precipitate when mixing together oil grades that differentiate dramatically by their properties. It occurs as a result of oil settling, for example, increasing the density of the formed mixture. American scientists from the API Petroleum Institute have proved that the effect of oil incompatibility can be reduced by the maintenance of permanent homogeneity and uniformity through agitation. Operation of a jet engine consists in the creation of a high-speed jet from the engine nozzle, enabling the aircraft to move forward. The higher the jet speed, the higher the thrust. The thrust enables heavy aircrafts to fly into the sky, and all this is achieved through the mixing of airflows. The FNAC company has decided to borrow such a solution and use it for mixing liquid in highly viscous media in large quantities. So we need to provide permanent homogeneity and uniformity of a mixture through continuous agitation. We suggest using the FNAC jet mixing devices for this purpose. This device has the following operating principle. The device is mounted onto the bottom of a vessel. The liquid is delivered with the same pump that is used for filling the tank. First, the liquid passes through the primary flow transducer into the main pipeline of the device and is then delivered to the flow distribution unit. From there it is fed into several straight line sections, oriented to different directions. In each straight pipe, the liquid perceives laminar motion, when all particles of the liquid move uniformly along parallel trajectories. The liquid is compressed when approaching the nozzle and accelerated out when passing through the nozzle opening. The jet speed may reach 50 meters a second at the nozzle outlets. Being torn away from the bottom and set into motion, dense particles of oil sludge are sucked through the conversion pipe with a speed of 1 meter per second. At the boundary between the conversion pipe and the mixing chamber, the sucked liquid with all dense inclusions is broken with a high-speed jet to a split, dispersed state. Now the flows become turbulent and move within the mixing chamber. In turbulent condition, the particles of the liquid move along closed chaotic trajectories, thus causing effective mixing of the main and the sucked flows. Finally, the turbulent jet aligning towards the outlet is pushed from the mixing chamber and moves against the tank wall, spreading and entering the neighbouring layers of the liquid. The outlet flow speed is sufficient for tearing the precipitated oil sludge particles off the bottom and bringing them into a suspended condition. The jet speed at the tank wall must not exceed 1.5 meters per second. Flows generated by the device may encounter some product warming pipework, subsurface fire suppression pipelines, and finally floating pontoons with their floats and supporting pillars. Having reached the tank wall, the liquid flows are reversed towards the device. Thus, the device creates circulating liquid flows within the tank, providing uniform physical parameters of the medium and the total absence of oil sludge. Each FNAC jet device is calculated individually and designed for a particular tank. Our device has much in common with a jet aircraft because we use for calculations the same software and 3D modelling as in the aircraft industry.